Hello everyone. Today in this video we'll start another subject, that is strength of material. So in this video we'll discuss some MCQs which have been asked previously in different exams. So particularly we'll be considering the SSC JEE question. So we'll be considering the previous year asked SSC JEE question. So for this video we are going to discuss the questions from properties of material and simple stress, strain and elastic constants. So without wasting time, let us move forward and start our discussion on these chapters. So first chapter that is we are considering here, that is properties of material. So for this chapter, first question is the strain energy stored in the body due to external loading within the elastic limit is known as what? Okay, so strain energy stored in a body due to external loading within the elastic limit is known as what? Resilience. So for that reason your D option will be the correct answer here, and it was asked in 2007 SSCG. So next question number 2, proof resilience in a member is stored strain energy in a whole volume, we can say. So proof resilience in a member is stored strain energy. So this is the stored strain energy in a whole volume or per a particular whole volume. So B option will be the correct answer here. So it was asked again SSC JEE 2008. So let us check the answers over here. So for this question number 1, D option will be the correct answer, and for question number 2, that B option will be the correct answer. Moving next, the resilience of a material is considered when it is subjected to, okay, so when resilience is comes into account, so that is frequent heat treatment or fatigue or creep or shock loading. So resilience, it is the amount of stored energy, we can say. So whenever your shock loading is applied on any material, then their resilience comes into account. So D option will be the correct answer over here. Then moving towards question number 4, the ability of a tool material to resist shock or impact forces is known as what? So that is known as toughness. So ability to resist shock or impact forces is known as toughness. So here option B can be the answer. Let us check the all the options over here. So A, that is given wear resistance, that can be the answer, and C is red hardness, and D is machinability. So here correct answer will be option number B. Okay, so if we'll check for question number 3, D is the correct answer, and for question number 4, B is the correct answer, that is toughness. Moving towards question number 5, and that will be the from the next chapter, that is simple stress strain and elastic constants. So that is a question number 1 we are taking here. Which of the following is a dimensionless quantity? Okay, so shear stress is having some dimension, that is in terms of Pascal or megapascal, you can say. Bulk modulus also having some dimension, but Poisson's ratio has no dimension, because Poisson's ratio is the lateral strain divided by your longitudinal strain. Okay, so strain has no dimension as well as we know. So it is the ratio of two strains. So this is the dimensionless quantity, we can say. Shear modulus, it is again having with dimension. So C option will be the correct answer over here. Then question number 2, percentage elongation during tensile test is indicative of what? So elongation is related to what? Our ductility. The material which is having with good ductility, so it will having a good number of good length of elongation, we can say. So ductility is the property. Okay, so the percentage of that is elongation tensile stress is indicative of what? That is ductility. So elongation shows the property ductility. So here option C will be the correct answer. For the question number 1, C is the correct answer, as well as for question number 2 also C is the correct answer. So you can check it over here also. Then moving towards question number 3, So on the application of the given load, okay, so for a particular load, the length of a wire is stated to increase by 1 mm. So for a given load, a particular length is being increased by 1 mm. So if the same force is now applied to a wire of same material, okay, so same force is applied and with the same material, but the length and the radius is twice the first, then extension produced would be what? Okay, so let us try to find out the extension over here. So we know that del L, that is change in length, we can say that is equal to PL by AE. Okay, so where P is the load which is being applied and L is the original length, A is the cross sectional area, and E is the Young's modulus of elasticity. So here if we see, so previously it was when suppose we are telling length was L, okay, that elongation was 1 mm, and again in the next case it is telling that same force, means P is not changing, okay, P remains constant, and then material is same, means material property, so E is the material property, that is Young's modulus of elasticity is the material property, so that is also not changing. But what is changing, that length is changing, okay, so length is becoming twice, so I can write 2L, okay, over here. These two are constant, so that we can neglect this one, okay. So length is changing, that is becoming 2L, and area, so radius is changing, so radius becoming R. So let in the previous case it was R, but in the next case it is becoming twice of the R. So for calculating area, we can say area will be equal to what? So area we can write pi r square. Okay, so pi is the constant one, that is not changing, but here r is changing. So instead of r we need to write 2r over here. So 2r square, that will be equal to 4r. I can write 4r square. So changes whatever made I have written over here. So from here if we'll calculate the del L, and by putting all those formula, matlab all those values, constant values, P is constant and E is constant, okay. So previously we can say PL by AE, okay, so that was okay, so that is equal to again A by replacing A, so A was pi r square into E, so PL divided by pi r square E, that was 1 mm, okay. So now we need to calculate the what extension del L, so that will be equal to what, 2 by 4, or I can write 1 by 2, so we can calculate that as 0.5. So for this question your B option will be the correct answer, that will be 0.5. let us check it. So here you can get also 0.5 is the answer. So here we can calculate del L is equal to 0.5. Let us move forward towards next question. So consider a bar of length L tapering from, that is tapering uniformly from diameter D2 to D1. So bigger diameter is being given as D2 and smaller diameter is given as D1, and subjected to an axial load that is given W. So extension produced on the bar will be what? So extension, if we'll be putting that formula, actually PL by AE, okay. So P is given as W over here, okay. So load, external load that is being applied W, okay. Original length, that is L, E is the modulus of that is Young's modulus of elasticity. So here if we'll be calculating A, so that can be calculated pi D1 into D2, okay. So normally if we'll be calculating like this, so your extension formula, extension of bar can be calculated by, that is your pi by 4, okay. So that is not pi d1 by d2, that will be equal to pi by 4 d1 d2, okay. So if we'll be taking this 4 into the numerator, so we can write 4wl divided by pi d1 d2 into E. So if we'll check all the options over here, So in the option number 1 we are getting our answer. So that is 4WL divided by pi d1 d2 into E. So here A option will be the correct answer. Moving towards next question. Poisson's ratio is used in which dimension? Option A is telling that one dimension body, option 2 two dimensional body, three dimensional body, or option D, that is both two and three dimensional body. So if we check, then Poisson's ratio can be applied both two and three dimensional body. So here option D will be the correct answer. So it was asked in 2008, is year 1. Okay, so here Poisson's ratio can be applied both two and three dimensional bodies. So here D option will be the correct answer. Let us check it. So we can get D option as our correct answer. Moving towards next question, towards question number 6. So which is the correct expressions over here? So if we'll see E, so is the Young's model of elasticity, and C, so we can write the relation like this. E will be equal to, that is 2C, so C or G you can say, that is the shear modulus, okay, into 1 plus mu. Okay, so 1 plus mu, or we can write mu as 1 by m. Okay, so 1 by m. So no options are given like this. So here options were wrong, so we can say none of the options are correct over here. So it was a wrong question, was given in 2008. So you may be getting the grace mark over here. So let us check. So no options are correct over here, so it will be getting the grace mark over here. Okay, so no options are correct. Moving towards question number 7. Hooke's law holds good up to what? Hooke's law, okay, so in case of your stress strain diagram you will see. So for ductile material we can check. So for limit of proportionality up to limit of that is proportionality, your Hooke's law holds good. So generally we can say Hooke's law holds good up to your limit of proportionality. So B option will be the correct answer over here. Let us check it. So we can see B option is the correct answer. Moving towards question number 8. The percentage reduction in area in case of your cast iron when it is subjected to a tensile test is of order of what? Okay, so cast iron, we know it is a brittle material. Okay, so there will be no elongation. Okay, there will be no reduction in area, so there will be direct failure. Okay, due to the ductile testing. Okay, tensile test, if you will be doing any tensile test on your cast iron, then there will be direct failure, there will be no reduction in area. So option A, that is 0% will be the correct answer. So we can say A option will be the correct. Then question number 9. When a wire is stretched to double in length, okay, so the that is longitudinal strain produced in its, okay, so we need to find out the strain over here. Suppose any wire is there, okay, with the length L and it is being stretched to another, okay, equal length. So we can say here del L equal to L, okay, and original length is again L. So that is longitudinal strain, we can say that is change in length by original length, that is L by L, so that will be equal to 1. So option B is telling that whether your longitudinal strain is 1. So option B will be the correct answer over here. So longitudinal strain can be calculated as 1. So let us check it. For question number 8, 0% is the answer, and for question number 9, 1 is the answer. Moving towards next question, that is question number 10. If equal and opposite forces applied to a body tend to elongate it, okay, and the stress produced is called what? Suppose any body is there and equal and opposite forces are acting upon that body and it is trying to elongate, so we can say that the tensile forces are being applied on that body. So which type of stresses will be produced in that body? So you can say tensile stresses. So B option will be the correct answer over here. Let us check it. So you can say B option is the correct one, that is tensile stress. Moving towards question number 11. The strain energy stored in a body due to direct stress F. So F is denoting the stress over here. So we need to calculate the strain energy. So that the strain energy, we know that formula sigma square B by 2E, where sigma was the stress, but in this case F we are taking as stress. So if we will be seeing that option C is matching to our option. Okay, so F square V, that is volume, divided by 2E. So C option will be the correct answer over here. Let us check it. So you can see C option is the correct one. Moving towards next question, towards question number 12. The modulus of rigidity is the ratio of what? So modulus of rigidity is the shear stress to shear strain, ratio of shear stress to shear strain, that is known as your modulus of rigidity, or we can say shear modulus. So here you can say C option is matching with our answer. So C option is the correct one. Okay, so here C option will be the correct one. Moving towards question number, so let us check it and we can get our C is the correct one. Moving towards question number 13. The elastic constants E, G and K are related by which expression? Okay, so we can remember that equation, that is equal to E will be equal to 9kg divided by 3k plus g. So let us check which option is matching to our answer. So if we will be saying that D option is matching with our answer, that is 9gk divided by 3k plus g. So here you can say D option is the correct one. Then for question number 14, the cylindrical rod of length L and the diameter is given D is rigidly fixed at its upper and hangs vertically. Okay, the elongation produced in the rod due to its self weight. So due to self weight, what will be the elongation? So that have the formula. So if you know that that will be equal to WL by 2AE. So here you can say, so this is wrong one, this is wrong, this is wrong. So here B option will be the correct one. So elongation due to self weight, that will be equal to WL divided by 2AE. Okay, so for question number 13, D option will be correct one, and for question number 14, B option will be the correct one. So you can check it over here also. So question number 15, the true stress represents the ratio of what? So true stress represents what? Instantaneous load to instantaneous area. So at a particular instant we need to calculate the value of load as well as area, so that we can find out the value of true stress. Okay, so generally we are plotting the graph between your engineering stress and engineering strain, but if we need to calculate the value of your true stress, then we need to consider the instantaneous load and instantaneous area. So here we can say D option will be the correct answer. Then moving towards next question, that is question number 16. Which material has the highest value of Poisson's ratio? So if we see, so Poisson's ratio is generally varying from 0 to 0.5, and 0.5 is what the value of Poisson's ratio for the material rubber. Okay, so you can see, so normally if we will be trying to say from the layman point of view, so Poisson's ratio is the lateral strain by longitudinal strain. So if we will be saying, so there will be minimum change in dimension of your lateral with comparison to your longitudinal dimension in case of your rubber. So your Poisson's ratio will be maximum in case of your rubber. So here you can say A option will be the correct one. So for question number 15, your D option will be correct one, and for question number 16, your A option will be the correct answer. Next, moving towards question number 17. The deformation per unit length in direction of the force is known as what? The deformation per unit length in the direction of force. Okay, so we can say, suppose this is any body and we are applying any force, okay, tensile force, let, okay, so and deformation per unit length, so that will be, we can say, any strain. Okay, so it is the it is here it is the deformation per unit length, so we can guess that it is will be a strain over here, and along the force, okay, along the direction of force, then we can say it will be the linear strain. Okay, so first catch was here that deformation per unit length, so it can't be the stress, so it can be the stress, and it can be okay, along the direction of force means it will be the linear stress, it can be the lateral strain. Okay, so here C option will be the correct one. Then moving towards question number 13, the tensile, okay, in a tensile stress, the specimen, okay, the ratio of maximum load to the original cross sectional area, okay, in the test is called as what? Okay, so in a basically tensile stress, the ratio of original maximum load, okay, where we can getting the maximum load or maximum stress, that is the at the ultimate point will be getting the maximum stress. Okay, so our maximum load can be applied at the what, that is your ultimate point. So load per cross sectional area, that we can say your stress, then maximum load we are applying. Okay, so we can say it is as a ultimate stress. So this can be the all the answers, so here A option will be the correct answer. So for question number 17, C is the correct answer, and for question number 18, A is the correct answer. Moving towards question number 19, a steel bar is fixed at both ends. Okay, so particularly suppose this is any bar and it is being fixed both ends. Okay, material is given is steel. If the bar is heated, suppose we are giving some heat over here. Okay, so we are heating the material, then it will develop what? Okay, so basically thermal stress will be developed here due to okay, thermal expansion will be there due to temperature, right, or due to heating of that material. It will try to expand, but as this material is fixed over here, so as this is fixed, it can't expand, so there will be a that material will be trying to expand, but this what your fixing element, we can say, so that is resisting it, so we can say a compressive stress will be developed inside that material. So here A option will be the correct answer. Moving towards next question, that is question number, okay, let us check it. Here we can see option A will be the correct one. Then moving towards question number 20, the value of Poisson's ratio is always less than what? So already I have discussed you minimum, that is the minimum value that may be 0, and it is maximum value that is your 0.5. okay, and this is in case of your rubber, so it will be always less than 0.5, that is will be the answer. So D option will be the correct answer over here. Then question number 21, stress due to change in temperature, okay, stress due to change in temperature develop in the bar depends on what? Okay, so whatever stress will be developed inside that material, inside any material which is due to change in temperature, then it will depend on what? Obviously it will be depending on the coefficients of thermal expansion of that material. So every material is having some coefficients of thermal expansion which is being denoted by alpha. So stress of that material will be dependent on your value of alpha. It will not depend on your thermal conductivity, density, or Poisson's ratio. So here you can say A option A will be the correct answer. Then we can check for question number 20, option D is the correct answer, and for question number 21, option A is the correct answer. Moving towards question number 22, for a material with Poisson's ratio 0.25, so let the Poisson's ratio, let is that equal to mu is given 0.25, and the ratio of modulus of rigidity, okay, so that is G divided by modulus of elasticity, so that is E. So we need to calculate this value. So if we can remember this relation, so E is equal to 2G into 1 plus mu. Okay, so all these values are given here and we need to calculate G by E. So for that, it will be taking E to this side and this whole term to this side, left side. So you can calculate G by E, that will be equal to what? That will be equal to 1 by here 2, and this 1 plus mu is given as 0.25, so this will be equal to 1.25. so we can write 2 into 1.25. so if we'll be calculating this value, then that will be equal to 1 by 2 into 1.25, that will be equal to 2.50. okay, so 2.50, so I can write it by 10 by 25, so that can be calculated as 0.4. so 0.4 will be the correct answer over here. So in this options, so option A is giving the answer, that is 0.4. so option A will be the correct answer over here. Then moving towards question number 23, if the equal and the opposite forces applied to a body, okay, so I think this question is repeated again, so you can say, so option A is the correct answer, that is tensile stress. So let us check, in both question number 22 and 23, your option A are the correct answer. Then moving towards question number 24, Poisson's ratio is defined as the ratio of lateral strain by longitudinal strain. So already we have discussed about it, so C option is the correct answer over here. Moving towards question number 25, the diameter of core to the circular section, okay, diameter of core of a circular section is given by, so that is D by 4. okay, so D by 4 is the diameter of core of a circular section, the section that will be, so here you can say D option is the correct answer. So if we'll be finding the radius, then I can calculate D by 8. okay, so do remember these values. So we can check the options, that D option is the correct answer over here. Moving towards question number 26, in a composite bar, the resultant strain produced will be, okay, so resultant strain will be equal in both the, okay, any materials may be there, okay, so it will be same as the strain produced in each bar. So whatever strain will be produced in each bar, that will be equal. Suppose we are telling we are taking three materials are composited with each other, okay, and whatever strain will be produced, that will be equal in all these three materials. So here you can say option A will be the correct answer. Let us check it. So option A is the correct answer. Moving towards next question, in a homogeneous isotropic elastic material, the modulus of elasticity E, G and K, so already we have discussed about it, that is equal to 9 kg by 3k plus G. okay, so here we can see C option is the correct answer. Moving towards question number 28, okay, so it is 28, the volumetric strain of a rectangular body subjected to an axial force in terms of linear strain, okay, so linear strain is given by small e and the Poisson's ratio is given by mu, so we need to calculate the volumetric strain. So volumetric strain, that we can write that will be equal to sigma, suppose there are different stresses, so that will be equal to sigma x by e, okay, plus we can say that is equal to, sorry, that will be minus, okay, sigma x by e, that will the along the x direction, then minus sigma y, okay, mu, okay, by e, minus that is mu sigma y by e. So you will be taking sigma x equal to sigma y equal to sigma z, okay, so this is a sigma z, sorry, so let sigma x will be equal to sigma y equal to sigma z, let it is equal to sigma, then we can write, we can take common, okay, so that is sigma divided by e can be taken as common, So it will be writing here, then I can write 1, okay, 1 minus here mu and here mu, so we can write 2 mu over here, and sigma by E we can write E over here, okay, sorry. So we can check, so that will be B option will be the correct answer over here, that will be E whole into 1 minus 2 mu, okay. So where E is the longitudinal strain or linear strain, okay, that will be equal to sigma by E. So here we can check B option will be the correct answer. Let us check it. So we can find out B option is the correct answer, that will be equal to E, okay, whole into 1 minus 2 mu, okay, where E equal to what, that will be equal to sigma by E, okay. So with this we have reached at the end of lecture for today. So if you like these videos, then press on the like button given below, and till now if you have not subscribed our channel, do subscribe it and press on the bell icon, so that you will be getting all the notifications of the videos whenever we will be uploading. Okay, so thank you for watching, and do share it, so that it will be beneficial to our channel. So thank you for watching.